Hello everyone, we are the students of IIIT Hyderabad. Today I am going to demonstrate a project real-time event monitoring system using Spark. So what is event monitoring system? Event monitoring system is the process of collecting, analyzing and signaling event occurrences to subscribers such as operating system processes, active database rules as well as human operators. In present scenario, world is facing the problem of huge data. So analyzing the old data is almost impossible. We have to do it on the fly. For this current project, we are using two tools. The first one is Apache Spark and the next one is NLTK. So coming to Apache Spark, we use Spark to run Spark job on Python. The advantages of using Spark is that it is lightning fast. Hadoop comes under Generation 2 distributed computing, whereas Spark comes under Generation 3 distributed computing. It also supports a rich set of high-level tools like Spark Streaming for stream processing. Apache Spark is an open source processing engine built for speed, ease of use and analytics. If you have large amounts of data that requires low latency processing that a typical MapReduce program cannot provide, Spark is the alternative. Spark performs at speeds up to 100 times faster than MapReduce for iterative algorithms or interactive data mining. The second tool which we are using is NLTK. It is a Python package which is used to process human language data. We use it to find the similarity between two words. The purpose of NLTK is explained in the further sections. So coming to the algorithm, Twitter data is considered as an input streaming data. Millions of tweets are posted on Twitter every day. So these tweets can be used for real-time event monitoring. We obtain the tweets using Twitter streaming API of Java. The input is taken in the form of dstreams by a Spark Python job. On these dstreams, we try to apply map and reduce functions on Spark by which we get the occurrence of a particular hashtag. When we get a peak in the timeline versus tweet count graph, we can consider this as an event. So this is a brief overview of our project. We take the Twitter stream. The Twitter stream is given as an input to the Spark. From this Spark, we try to get the tweets which are in the particular hot topic event. Coming to the next step, we do sentiment analysis on these tweets based on hot hashtag. Consider all the tweets related to that hashtag and compute the tweet rank. What is tweet rank? It is defined as a tweet with highest pairwise cosine similarity with all other tweets. It is proved in many existing methods that the text with highest pairwise similarity has the highest content in it. Tweet with highest rank will be displayed to the user. So as I mentioned before, NLTK is used to find the similarity between two words. This is the high level design of our project. And coming to the coding part, this is the Java code which generates the Twitter stream. These are the access tokens which are provided by the Twitter API. If we run this code, these are the outputs which are generated. Hashtags is the file which contains the hashtags from the current stream, and tweets is the same, but it also has a body. And coming to the next part, this is the Python code built on Spark. Here we try to use map and reduce functions provided by Spark to find the occurrence of the tweets. This is how we run a Spark job. Okay, the code for Spark has ended. As you can see, the input provided for the Spark job is here. It contains around 3000 tweets. It has processed all the 3000 tweets within seconds. and the next code is to cluster the tweets based on a particular hashtag. So once the tweets are clustered based on a particular hashtag, we have to find the pairwise cosine similarity. We use NLTK for this, and this is the part where we are finding the similarity between two words. Once we find the pairwise similarity of all the tweets, we print the topmost two tweets. This code will take a while because NLTK has a large dataset and it has to process the words and find the similarity. Yeah, the code is done. So these two are the outputs which I have got from the pairwise similarity. The first one is, this is the second strong earthquake felt in Merida, Venezuela in the last 15 hours and less than 20 kilometers away. And the second tweet is, felt earthquake of magnitude 5.1 strikes in 25 kilometers west of Merida, Venezuela 14 minutes ago. Please report at some website. So coming back to the results, a live Twitter stream is given as an input. The code is ran at different time periods and following are the events which are treated at the time span as hot topics. The first one is earthquake occurred in Afghanistan and earthquake occurred in Venezuela. As we can see, various natural calamities can be monitored by using this tool. In the above example, it detected an earthquake in Afghanistan and Venezuela. We collected the data at 1 am on 22nd of November and earthquake actually occurred around 12:30 on 22nd November. As another example, the code also detected the trending event that Djokovic bet Federer in ATP finals, which happened the night where we ran the code. Coming to the conclusion, in this project we have devised a method monitoring events in real time using Apache Spark. For evaluation, we have tested on Twitter streams at different times. We got very good results and we are able to monitor the events. This tool can be applied in monitoring various natural disasters like earthquakes and tornadoes. So coming to the references, this is the main reference paper which we are using as a base idea. This is how we extracted the Twitter stream, and as we are new to code in Python using Apache Spark, we use this reference, and this is to find a similarity between two words. Following are the links which you can find online. Thank you.